What's going on, Safemoon family, Safemoonarmy? Thanks again for joining me for yet another video. If you are new here or have not subscribed, subscribe, smash that like button, share this with all your friends. Just so you know, I'm not a financial advisor. Anything you hear or see in this video is not financial advice. On today's show, we are covering a massive leap in technological advancement in Safemoon. So strap in because here we go. Alright, we're going to start off right here, right now at safemoon.education, just so everyone is aware. V2 is out, and if you go to safemoon.education, you can go over to guides, and you scroll down to here where it says Safemoon V2, learn how you can consolidate to Safemoon V2 and what has changed during the consolidation process. And if you click here on learn more, you'll see all the different ways that you can migrate over to Safemoon V2. I just wanted to let you guys know that this is the place where you probably want to go to get any of your information about consolidating to Safemoon V2. Okay, time to get bonkers. Let's fly on over to this. During the AMAs yesterday, John Caroni brought up some crazy things that Safemoon has been working on in the background, and here was a question that was asked to him after the AMAs. It says, when massive leap in technological advancement? And John Caroni replied, already there, the hydrophobic and the hydrophilic nanoparticles are being applied to the turbines at Area 32 by the Dark Moon team. They are getting me hyperspectral imaging and other scans and data. So these two words up here I could not actually even find in a Google search, and I believe that he meant hydrophobic and hydrophilic rather than these two words because neither one of them come up in a Google search. So for the sake of argument, the words that I could find that really resemble these two words are hydrophobic and hydrophilic, and I'm going to be using those words when describing the nanoparticles. And let's go over to what hydrophobic is. Hydrophobic is a property of a substance that repels water. It means lacking affinity for water and tending to repel it, not absorb water. Hydrophobic molecules tend to be nonpolar molecules and grouped together. Oils and fats are hydrophobic. Hydrophobic materials often do not dissolve in water or in any solution that contains a largely aqueous environment. Hydrophobic materials are often used to remove oil from water, manage oil spills, and chemical separation processes that require the removal of nonpolar substances from polar compounds. Now, this is the part I wanted to focus on. Hydrophobic surfaces decrease corrosion rates and therefore are used in corrosion resistance. The opposite of hydrophobic is hydrophilic, water-loving. Surface active agents contain both hydrophobic and hydrophilic groups on the same molecules. Hydrophobic may also be known as hydrophobicity. Now, what did I want you to pick up from all that? Hydrophobic surfaces decrease corrosion rates and therefore are used in corrosion resistance. That's the main thing I wanted you guys to pick up from this information. Now let's fly on over to this. This is the hydrophilic coating. What does hydrophilic coating mean? A hydrophilic coating is a coating that has the affinity for water. The term hydrophilic means water-loving. Therefore, these types of coatings tend to attract water rather than repel it. Hydrophilic coatings readily spread water around the object when exposed to moisture and thus enhancing its lubricity and significantly reducing surface friction. Okay, so now you guys see there's surface friction reduction here, there's corrosion reduction in the last one. Alright, now that we have some sort of idea what these two nanoparticles are all about, let's go back to John's Discord conversation. He also said they are getting me hyperspectral imaging and other scans and data. Well, what exactly does that mean? Let's fly on over here to USDA.gov, and this was an article published, Wind Turbine Blade Defect Detection Using Hyperspectral Imaging. So I'm just going to read through this so you guys understand why he would actually want a hyperspectral imaging scan of these turbines. Regardless of the evolution in the wind turbine industry, the operation of wind farms faces critical challenges when it comes to maintaining the lowest possible cost of energy. It is essential to early detect or predict wind turbine breakdowns due to different factors such as material degradation, electrical and mechanical failures, faults, or environmental damage. Wind blades are the most expensive and most exposed parts of the wind turbine and suffers from many shortcomings, mainly cracks and erosions which reduce their performance. Hence, there is an essential requirement for using non-destructive diagnostic of wind turbine blades. Now, if you read down here, it says, thus this paper describes hyperspectral imaging implementation in image acquisition, handling, and flaw recognition, as well as the detection of cracks and erosion. This technique field outputs results show the blade's defect detection accuracy and precisions are significantly enhanced. So what does all this imaging do? This hyperspectral imaging helps you detect the cracks and erosions in the blades. Now let's fly on over to this article. It's Materials for Wind Turbine Blades. A short overview of composite materials for wind turbine applications is presented here. So if you read down here under Neo-engineered polymers and composites, you can see this guy and his colleagues developed various wind turbine blades with secondary carbon nanoparticle reinforcements and demonstrated that the incorporation of these small amounts amounts of carbon nanotubes and CNTs can increase the lifetime up to 1,500%. That's crazy. They also found that reinforcement for this nano modification of wind turbine composites, and it showed experimentally that the graphene reinforcement is very promising in developing for a stronger, long life turbine blades for the wind industry. So with these developments that John Caroni was talking about and these scans that he was looking at, you could be looking at wind turbines that last way longer than any other wind turbine out there. Well, what else did he talk about? Let's go over to this other information drop on Discord. John Caroni was asked on Discord, so are you using synthetic lube to make less friction on windmills? John Caroni responded, nope, it's actually manipulating how air interacts with the blades themselves, i.e. essentially enhancing the airfoil to increase efficiency. Okay, so we just talked about nanoparticles and how they could be used to strengthen the blades of a wind turbine. Now we're going to be looking into manipulating the airflow and how it interacts and enhancing the airfoils to increase efficiency. So let's dive into this because this is where it gets super interesting, guys. We're going to fly on over to this. This was something that was posted on July 16th of 2021. Notice it's an owl in front of a moon, and notice this on his ankle, it's a chain. Well, gee, that's kind of interesting. Well, if you swing on over to this article that I found, it says more efficient wind turbine blades designed inspired by owl wings and feathers, incorporating the cross-section airfoils of an owl's wing coupled with the herringbone groove structure of the owl's feature leads to better aerodynamic performance for wind turbine. Guys, what the hell? You mean to tell me that they've been hinting all along that with these owls that they were using these more efficient wind turbine blade designs based on the owl's wings and feathers? Now, if you scroll down here through the article, you could see as wind turbines convert the kinetic energy in wind to clean renewable electricity. Even environments with low wind speeds can take advantage of wind power with the optimization of blade design. Improvements in aerodynamic performance of blades will lead to a boost in power generation efficiency of wind turbines. And if you read down here, it says using modeling software, the researchers modified a prototype blade to fit the cross-section airfoils of long-eared owl wings to create a bionic airfoil blade. After closely observing owl feathers through a microscope, they added a herringbone groove structure to form a bionic coupling blade, since the microstructure of the feathers play an important role in efficient and high mobility bird flight. Now, they did test this out with a couple of other birds, and the only feathers that they saw that had the most promising was the owl feathers. Geez, put that into your brains for a second now, guys. They've been toting about owls this whole time. And if you read down here, it says the scientists evaluated the performance of all three blades, the prototype blade, the bionic airfoil blade, and the bionic coupling blade, with numerical simulations finding the pressure difference between the windward and leeward surfaces of the bionic coupling blade is larger than the other two blades. Small vortices appear in each depression of the herringbone groove structure, which increase the local flow velocity of the leeward surface on the bionic coupling blade. Now, if we fly on over to the investigation of aerodynamic performance of a wind turbine blades coupled with the airfoil and herring groove structure, I know it's a lot to take in, but the increase of pressure difference between the wind side and the leeward side of the blade is the main reason for the improvement of the aerodynamic performance of the blades. The airfoils, now remember, that's something he said in his actual conversation on Discord, the airfoils of the owl wings and herringbone groove structure make the blade have a greater pressure difference. The larger curvature of the leading edge of the blades leads to a larger flow velocity, which leads to smaller pressure on the leeward surface of the blade, and the increase of pressure on the windward surface is due to the concave of the blade. The herring groove structure reduces the local pressure of the blade surface, and all this generates great efficiency within the blade of the wind turbine. Now, if you want to see what this looks like, this is a diagram, and this is where they place these little herringbone that they got from the owl's wings on these different turbines to see what gave them the most efficiency, but they are getting great improvements in wind efficiency now with these small advancements in the wind turbine blades due to examining the wings of an owl. Now let's fly on over to this, and this is the one thing that I wanted to finish up with right here because this is super interesting. Wind turbine de-icing with active thermal nanotechnology coating. It's from this company called WindGo, and if you read down here, it says WindGo nanotechnology helps wind energy industry save up to 20% with thermal coatings. Now, the biggest thing I wanted to focus on in this article down here is it says WindGo Inc. is focused on the IoT end node market expansion that is forecasted to exceed $1 trillion by 2025. This new invention is based on technologies that evolved from the original works of inventor Fielding Station. His invention of the absorbent in 2013 has led to the industry changing game-changing advancements in macro and micro and nano-based technologies. Guys, did you hear that? The IoT end node market expansion is forecasted to exceed $1 trillion by 2025. That is insane. All right, guys, that's all I got for you today. If you liked it, subscribe, smash that like button, share this with all your friends, and I'll see you in the next video.